Hello friends, I welcome you in lecture number 35 on logic. In this lecture also we will discuss one more question on quantifiers, and this question was asked in GTU Summer 2022 exam. Here we are asked to show that there exist xpx and there exist xqx and there exist x such that px and qx are not logically equivalent. We know that two statements or propositions are logically equivalent if they have the same truth value. So if we want to prove that these two are not logically equivalent, we have to find out two statement functions px and qx for which these two are having different truth values. So for that, first we consider domain of these two statement functions or universe of discourse. Consider universe of discourse, which is another name for domain, as this set of integer which we denote by z, and we consider px as we consider those those integers which are positive. So px is the notation for x is positive, and we consider qx as x is negative. And first we check for this statement. First we find out what is the truth value for this statement. So first we check whether this is true or not. There exists x px. What is meaning of this? This means that there exists x in this set of integers. There exists at least one x, or there exists an x in this set of integers such that x is positive, and we know that this is always true. We can consider x equal to 2, then p of 2 is positive. So p of 2 is positive, and that is always correct. We know that 2 is greater than 0. So we have x equal to 2 such that p of 2 is true, and we require at least one value of x. Otherwise we have infinite number of positive integers. So here we can write that clearly. P of 2, if px is x is positive, p of 2 is positive is true, and therefore we can say that this statement there exists x such that px is true. Similarly, qx is x is negative. So now it is clear that qx there exists x such that qx, that is also correct. What is meaning of this? There exists or there is an integer x in z such that x is less than 0, and we can consider x equal to say -2 or -3. Q of -3 is negative. Qx is the notation for x is negative. So if I take x equal to -3, I will have -3 is negative, which is true. So we find out at least one value of x such that there exists x such that qx is true. Now we have this proposition is true, and this proposition is also true, and we know that if we take conjunction of two propositions, then conjunction is true if both the propositions or statements are true. Here there exist xpx and there exist xqx, both are true, therefore their conjunction is also true. So truth value of this part is true. Now we check for another part. We have same notations px and qx, and now we have to check whether this is true or not. So here first we write down what is px and qx. Px is x is positive and qx is x is negative. So px and qx means x is positive and x is negative. And we have to check whether there exists x such that px and qx is true or false. There exists x such that px and qx. What is meaning of this? This means there is some x, there is an x such that x is positive as well as x is negative. So what do you think? Can you find out any integer which is positive as well as negative? So this is never true. We know that if we take any integer, then it is either 0, positive or negative, but same integer cannot be positive and negative at the same time. So here we cannot find out any x in this set of integers such that this is correct. That means this statement, there exists x px, there exists x such that px and qx is not true or is false. This is false, and here this is true. So truth value of this statement is true and truth value of this statement is false. That means these two are not logically equivalent. Therefore there exists x such that px and there exists x such that qx. This is another one statement. Another statement is there exists x such that px and qx. These two are not equivalent, or these two are not logically equivalent. Here they have asked to prove that these two are not logically equivalent, and we have obtained particular statement functions px and qx with the domain as the set of integers such that these two are having different truth values. This is having truth value t and this is having truth value f, therefore they are not logically equivalent. Two propositions are logically equivalent if they have the same truth value. We consider another question also which was asked in GTU Summer 2022 exam. Here we are asked to prove that there exists x px or qx and there exists x px or there exists x qx. These two are logically equivalent. This we can rewrite in this way also. There exists x such that px or qx is logically equivalent to there exists x px or there exists x qx. Here we are distributing this existential quantifier over this disjunction. There exists x p or q, that is logically equivalent to there exists x px or there exists x qx. Now these two are logically equivalent if they both have the same truth value, either both have truth value true or both have truth value false, then they are logically equivalent. So suppose we first think for this. What is meaning of this? This means there exists at least one x in the domain. Here these are arbitrary, so we consider domain as arbitrary also, but we restrict that both these statement functions px and qx have the same domain. So what is meaning of this? This means there exists at least one x such that px or qx is true. And we know that px or qx is true if either px is true or qx is true. That means this is true if there exists at least one x for which either px is true or qx is true, or there exists at least one x for which at least one of these two has truth value true. Now if we think about this part, here we have there exists x px or there exists x qx. What is meaning of this? There exists x px. This means there is at least one x such that px is true. This means there is at least one x such that qx is true, and we are joining them by disjunction. That means there is at least one x such that either px is true or qx is true. So we can say that both statements are true if for at least one value of x, at least one of these two are having truth value true. So truth value will be same for both of these. So you have to write systematically. I have written here. First I have written for this there exists x px or qx. This is true if there exists at least one x in the domain for which px or qx is true, and px or qx is true if at least one of these two is true. Therefore this is true if at least one of px and qx is true. Now for second part I have written there exists x px or there exists x qx. This is true if there exists x px is true or there exists x qx is true. That means this is true if for at least one x px is true or if for at least one x qx is true. And here also we have same thing, if at least one of these two, that is if at least one of px and qx is true. That means both statements are true precisely when at least one of px and qx is true for at least one value of x in the domain. That implies that these two are logically equivalent. And we have seen in previous example that if we replace this disjunction by conjunction, then they are not logically equivalent. These two are logically equivalent if we are using or disjunction, and if we are considering conjunction, then they are not logically equivalent. So this is nice question. It was asked in GTU Summer 2022 exam. So this is all about this session. I hope you like it. Thanks for watching.